Okay, we're recording. So welcome everybody. I'm Kathy Larson, and I'm working with a group out of Green Maynard that is working on a lighting bylaw. And we've invited Dr. James Lowenthal, who is the chair of the astronomy department at Smith College. I heard him speak in Stowe a couple months ago, and it was a excellent presentation. So I thought people would really be interested in hearing it here. And I'm hoping that you'll learn a lot about why we want to have a lighting bylaw and what all is involved with it. James is also the president of a group called Mass Dark Sky, which is, James, you can correct me if I word this incorrectly, but they're making recommendations for towns in Maynard. So they've been helping us a lot with our bylaw because these are the people who really are the experts in lighting bylaws. Anything else about Mass Dark Sky that you would want to say, James? And
It
I'll
was,
just turn it over to James. Looking forward to hearing what he says.
thank you so much. Thank you, Kathy. Thank you, Sally. Thank you, everybody, for coming. Thanks for hosting me, Maynard. And just a quick word. I'm actually right now in New York City, taking care of my elderly mom who has Alzheimer's. I'm saying this because at any moment, the door here could open and I might have to just duck out for a second, but um, maybe that won't happen at all. I want to start with this video, which I hope you can hear. You hear coyotes?
Yep.
This is high up at the top of the hill in Heath, Massachusetts, on the close to the border with Vermont, where I took some of my colleagues and students from Smith College on a dark sky field trip so they could see the Milky Way for the first time. One of my favorite things to do. Here is another field trip with students. And here you hear the spring peepers. That was up in Hawley, Mass. So we go to the dark places. We rent a school bus or a van and we go to the dark places. Here's another one. Here's the Milky Way setting over lovely hilltop apple orchard in New Salem, Massachusetts. Students are singing. That's always a good sign. Sometimes they cry, also a good sign. You know, it's an emotional thing. This is the favorite part of the semester for them when they go to this beautiful dark sky and they just bask in the light of the stars. Why can't we do that at home? Here, close to home, this is in Northampton, just a mile from campus, on a fairly clear night in the middle of winter. The Milky Way, you can barely see it. It was just in that view there. It's in this picture here. Why can't you see it? Well, here's part of the reason. If you turn your head around on that hilltop, you see those bright lights. And if we zoom in here, we see, oh, it's the county jail. And in fact, this location where I'm standing taking this picture is the location of three new houses built for Habitat by Habitat for Humanity, built for low-income residents who now have this as their backyard. I mean, it's shining right in their windows. The middle of downtown Northampton is not much better. It's a canyon of light. And if you were down in the bottom of that canyon and you tried to look up and see the stars, it'd be pretty hard. Where does all that light come from? Well, it comes from the bowling alley or this parking lot or this parking garage or the top of the parking garage, even though nobody's there, got to light it up all night long, or light up this parking lot all night long. It's from this one and that one and this one and that one. It's just all over the place. This is the city's own structure and garage right next to their downtown. If we go back over 200 years, we come to the first street light powered by gas lantern in Baltimore, Maryland. There are versions around today, like this one I saw in New Orleans a year ago, that are still burning gas and still have the power of about 50 candles. But more common, and I'm sure you know what I'm talking about, is you take one of these old-fashioned gas lanterns and you stick in it a really bright LED. How bright? 10 times brighter than that gas lamp. And here they are all lined up on a street right in the middle of downtown Northampton. So bright it's like daytime. And what does that do for romantic dining? Not much. It's not a very romantic view. You can see that guy there. He's got a migraine. Maybe that's why he's holding his head. I'm just guessing. But it's so hard to see from all the glare and the super bright overlighting. It was not done by obviously by an aesthete, and it was not done by a medical doctor who understands what the effect on humans is. Um, we tend to overlight everything. Here is the construction site of a roundabout right near the Connecticut River. It's in Northampton. It's the intersection of Interstate 91 and Massachusetts Route 9. And you can see the moonlight. The moon is there on the right, upper right. And this is before they installed the bright lights. And here is after they installed the bright lights. It's now 500 times brighter than it was on the night that I first took it with the moon. Do we actually need that much light? It's not just municipal and commercial structures, it's private residences too. Here are the lights on the side of the door of my neighbor around the corner from me. And again, they're evoking that sort of ye olde brass and glass carriage style lantern, but they don't have candles in them, do they? No, they've got bright LEDs. And at night when I go by there, I'm blinded by these bright LEDs. I have to shield my eyes so that I can see where I'm going. It's the opposite of good lighting. It actually makes it harder to see, not easier. Here's another example of a neighbor trying to do the right thing, trying to light up their walkway, but instead of lighting up the walkway, they're lighting up my face and my eyeballs, shining the light directly in my eyes instead of on the ground. Does it have to be that way? No. This neighbor did a great job of lighting up their walkway with down-facing lights, mellow, nice color, not too blue, amber, warm, totally shielded against glare. So the light's going down only, and it lights the thing it's supposed to light, which is the walkway and the stairs. Okay, so to summarize, this was an introduction about what light pollution is, so we can just wrap our minds around it. In general, light pollution is light that is excessive. It's light that is poorly aimed, so it goes in all directions. It's light that shines outward or even upward or shines into the windows of neighboring property where it's not intended and it's not useful. And it's on maybe all night long, even when nobody's there, like this empty parking lot in Northampton. Well, so what? Why is this a problem? Why should we care about it? And why might Maynard consider writing a good bylaw to try to curb light pollution? There are 5 main reasons. It's bad for human health. It's bad for human safety. It's a total waste of money and energy. It ruins the night sky, and it's bad for all other life as well. A little bit more on each of those. How is light pollution bad for health? It actually leads to elevated rates of serious diseases, including cancers that are hormonally driven cancers like breast cancer and prostate cancer and colorectal and several others. How could that be? Well, even before we understand the mechanism, we could just look at the numbers. And these are just 2 studies from among dozens out there showing these very high significance effects of linking light pollution and living in light polluted areas with higher, elevated rates of these serious diseases. For example, close to you, the Harvard Nurse Study. There's a famous study of over 100,000 nurses, women, for decades. So they had a huge database and they were able to mine it for many different kinds of projects. And one of them was look for a link between the rate of cancer, breast cancer in these 100,000 women and where they live. And it turns out the ones who live in the light polluted areas have a significantly higher rate of breast cancer. It's not just this study, it's also been done here in Spain. There's a map of Spain and it's a map of the light pollution. So you can correlate that map directly with the cancer rates. And lo and behold, it's a higher rate. And you might say, well, there are other There are other reasons it could be. It could be, pollution in big cities that they're breathing. You control for all of that, and there's still this very significant effect. So it's been done in big epidemiological studies many, many times over, and it just seems like a solid result. Cancer rates go up by um, as high as a factor of 2 in the presence of artificial light at night. Okay, now the mechanism. How could it be? How could it be that something as benign and useful and everyday as light could be associated with cancer? Here's the thinking. Your eye has a special function besides vision, and that is to look for the sun going down and to look for the drop in blue light that comes with the sunset. And then your eye sends a signal to the brain that says, start producing melatonin. And melatonin is a very important hormone that does numerous things, including resetting your body clock, your 24-hour circadian rhythm, but it's also a powerful cancer suppressant. In the presence of melatonin, which is normal every night for all of us, cancer tumors are suppressed. In the absence of melatonin, tumors are allowed to grow more quickly. This was verified in laboratory rats. The problem is we are now producing exactly that kind of blue light that your eye is looking for to, to, to dramatically drop with the sunset. This chart shows what colors of light are produced by different kinds of light sources. At the bottom, you see there's a fire. It produces barely any blue light at all. Like basically all the light is red light. And it suppresses, if you're in the presence of a lot of firelight or candlelight at night, you're essentially producing the amount of melatonin that your body is made to produce. The incandescent light bulb in the middle, it's about the same. It produces almost no blue light at all. But now look at the one at the top. That's supposed to represent an LED light that has that big blue bump there. That big bump of blue light is produced by the LED in addition to lots of other colors. It makes it look kind of, bright blue, maybe harsh color. And that's exactly a collision with the color of light your eye is looking for. And the result is we suppress the natural production of melatonin in our bodies by as much as 80%. Is it all LEDs? No. The good news is this is a solved problem, and you can choose LEDs that don't have that big blue bump. This chart shows the spectrum again. So blue is on the left and red is on the right. The x-axis, the horizontal axis is wavelength. Blue on the left, red on the right. And you see the red curve that says melatonin suppression. That's the curve of the sensitivity of your eye. All the other curves are the curves showing how much light is produced by different kinds of LED lights. And you see them labeled there, 2700K, 3000K, up to 5000K. And you'll notice the 5000K is that yellow curve. It's the one that has the highest blue bump. So that number there tells you how much blue there is. The higher the number, the more blue. 5,000 is much too much blue. 2700K is that red curve. You see how much lower that blue bump is. Much better if we're trying to protect our human health. There are two recent discoveries that help explain this link between the artificial light at night, ALAN, and cancer. And I referred to them previously, but it's worth noting how recent these are. One of them is the discovery of that special cell in your retina that we didn't even know about until about 20 years ago, whose sole job it is to look for that blue light. And that got a Nobel Prize. And the other one, sorry, this one got the Nobel Prize. The other one here is the discovery of the 24-hour clock, the genetic clock that is in every cell in your body, in the nucleus. The picture here shows a zoom in of a cell. The sort of purple oval is meant to represent the nucleus, and it has DNA in it that has several different mechanisms of 24-hour clocks. So how cool is that? Every one of the cells in your body has a 24-hour clock, and they all get reset every 24 hours by the sun going down and coming up and going down. And one of the main avenues for it getting reset is the light coming to your eye. There's a huge amount of research on this recently. If you do a search in PubMed on circadian rhythm and light and cancer, you get 10,000 studies. It's not just one or two. There's an enormous industry studying all these relationships among light and melatonin and health and cancer and in various ways. The problem, of course, is we no longer live in a regular cycle of very bright days and very dark nights the way it used to be. This plot shows the amount of light that we get in a typical day. And you'll see the blue curve there shows at midnight it was very dark, and at noon it was very bright, and then at midnight it was very dark again. The red curve shows that at midnight it's actually pretty bright now, and at noon it's not so bright anymore, and at midnight again it's bright. Why is this? Well, of course, during the day at noon, we're not outside. Most of us used to be outside under the bright sunshine. Now we're inside under less bright light. And at nighttime, we're surrounded by light, both indoors and outdoors. So we flattened out that curve in a way that is disruptive to the natural rhythms that our bodies are programmed for. All right, a little bit more about what this problem looks like on the ground and how we can control it. So here we have to understand how lights work and where they put the light. And this diagram shows a little bit about that. It shows a street light on the far left and a yellow cone of light coming down. That is the useful light. That's the light underneath the street light that will illuminate the sidewalk or the street or the parking lot or the pathway in a useful way. But you'll notice that there's other light coming out as well, including directly into that person's eyes, including into the windows of the building on the far right, light trespass, including even directly upward into the sky a little bit. Even though it has a hat on it, it's not well shielded, and some of the light is shooting straight up into the sky. So all of that is glare and light trespass. That person there uh, is blinded by that direct view of the lamp. It should be shielded so the light goes only in that yellow cone, but it's not. Here's a diagram showing what that would look like if you had three houses. The middle house has two lights on it. There's a light on the left that's poorly shielded against glare and light trespass. And you see the light shining up into the sky, and it's shining into the windows of the first house on the left. On the right side of the middle house, there's a light facing down only. And that's the way it should be. That's useful, and it's not going to bother the neighbors. Here's what the Federal Highway Administration says about glare. It's one of the most important elements to control. It affects your ability to adequately see, particularly for older drivers. Here is a view of a street right near Smith College campus in Northampton. That was the site of a near fatal collision just a couple of years ago on a rainy night. And this is what the driver would have seen on a dry night, and even worse on a rainy night, two bright streetlights shining directly in his eyes. And the victim was crossing the street right under those streetlights. So these are poorly designed. Instead of shining directly on only on the pedestrian, they're actually blinding the drivers. We all know what it's like to drive in the presence of glare. It's blinding. And it's especially bad for older eyes. This graph shows the ability of eyes to resist glare versus age. So on the left, young eyes are very able to resist glare. They can see in the presence of glare. But on the right, 60-year-olds, I'm 61 and older than that, we're not so able to resist glare and to see in the presence of it. So what does that look like? Well, you can probably speak from experience. On the left is how a view might look with a bright headlight in it if you had young, healthy eyes, and how that same view might look if you have a little bit of haze in your cornea or some early cataracts. That same spot of light turns into a veil of glare that really impedes your vision. So this is obviously a direct hazard on the road. And many people say, "Oh, I'm too old. I can't go out anymore at night. I can't drive anymore. It's not safe. My eyes are too bad." And my response to that is, that's not your eyes that are bad. It's the lighting that's bad. We should fix the lighting, not consign our elderly population to an indoor life at night if they don't want to. The American Medical Association has issued a number of statements about this, and here's one from 2016 saying, look, folks, for outdoor lighting, we should minimize glare whenever possible, and we should minimize the amount of blue light. We should not use any light bluer than 3000 K. That, remember that number, the higher the number, the more blue. Keep it to 3000 at the very maximum, ideally more like 2000. You might say, wait a second, wait, more light equals less crime. Isn't that right? Don't we need that light to prevent crime? Isn't it just safer? And the answer is no, it's more complicated than that. Here's a view of my street. That's the street light right outside my house. My car was parked directly under that street light, twice vandalized by thieves who came in the middle of the night, jacked the car up, stole the catalytic converter, let the car down, and went on to the next car. Did the light stop them in any way? Not at all. And in fact, this story is common. I've heard it from at least 3 other people around town. Car parked under the street light, catalytic converter stolen in the middle of the night. We don't need more lighting. We need better lighting. Here's an example of a backyard with a poorly designed security light that's shining in all directions. If only you could hold up your hand somehow and block the glare like this, you would see there's a guy standing there in the doorway. He's actually there in the first picture too. You just can't see him because of the glare. Light pollution is a pure waste. It's a pure waste. It's not helping anybody. Nobody benefits from it. It's estimated that at least a third of all the light that we produce is wasted going out sideways where it causes glare, it's not useful, or even up into the sky. That contributes to at least $3 billion of waste in the United States every year. Other estimates are much higher, as high as $50 billion of wasted money. And of course, we're burning fossil fuels largely to produce that electricity. So it contributes to climate change and local air pollution as well. Of course, light pollution robs us of the stars and the Milky Way. There on the left of that view of downtown Northampton with some of the brightest stars of the winter sky rising in the back. You can barely see them. The Milky Way, forget it. Whereas just 11 miles out of town at Smith's beautiful McLeish Field Station, so much better, so much more lovely. It makes people happy. Everybody wants to see the stars. And our students are so thrilled to go on a field trip just a few miles out of town to see the stars of the Milky Way. Here on campus, they're battling the downtown light pollution, and it's a challenge. I mean, look at all that light shining directly on our telescope dome. That's all coming from city lights and the college's own athletic field lights. This picture shows the result of different levels of light pollution on the view of the night sky. On the right side, and they're rated on a 1 to 9 scale called the Bortle scale, after John Bortle, who designed this. He came up with a scale where 1 is a pristine, excellent dark sky sight, and there are very few places with that rating in the United States. At the other end, Bortle 9, 8 or 9, is the middle of a big bright city like Times Square or Las Vegas or the middle of Boston. Your sky in Maynard is about a 5. So you can see what the effect on the Milky Way is there. You can just barely see it. And you've lost the great majority of stars from your night sky already. You can get them back, but you don't have them right now. We also said that light pollution was bad for wildlife. Artificial light at night is not the kind of light that animals are looking for. All of these animals need darkness at night to thrive, from birds to mammals to reptiles and amphibians to insects like the fireflies in the picture at the lower right. A little bit more about some of those. Birds migrate, you probably all know that, and the vast majority, something like 3/4 or 80% of birds in North America migrate. And this has been happening for, of course, tens to hundreds of thousands of years to millions of years. Since the last ice age, the map of migrating birds has looked something like this, from South America in our wintertime to North America in our summertime, including up to the far north of Alaska and the Yukon, and some of them stopping in New England along the way to nest. It happens at night. The migration happens at night. If you go to this website, Birdcast, which is a collaboration between UMass and Cornell, where some of the best ornithology programs are, then you can check in a dashboard for your location. This is showing the dashboard for Hampshire County, where I live, where Northampton is, on a particular night, May 12th, just last month. Look how many birds migrated across Hampshire County that night. 1.5 million. And those species are Baltimore orioles, all kinds of warblers and thrushes and tanagers and flycatchers, and 1.5 million birds, and they're flying overhead at night. It's so, I love this. I love realizing this. I didn't always realize this. I've come to appreciate it only recently. I go out on May nights now and I look up at the night sky and I just think, oh my God, there are thousands to millions of birds flying over my head right now. I have never seen them or heard them. Some people occasionally do see or hear them, but mostly it's this silent, dark river of bird life flying overhead at night. How do we know this? You can see it in weather satellites, not satellites, in weather radar. This is a video of weather radar. What you're seeing right now is mostly storms traveling across the United States. But look what's happening. Look, the blue sweeping from the East Coast across to the West Coast. What's that? That is birds taking to the skies as night falls, starting on the East Coast and then traveling across to the West Coast. As the Earth spins and night falls, the birds take to flight for their nightly migration. They show up in the weather radar because the numbers of birds are so high that the density is picked up by the radar. These clouds, rivers of birds. Here's the problem. Let's put two maps together, the map of light pollution and the map of bird migration. And you see they're very similar. The birds are migrating over heavily light polluted areas of, for example, North America. And what is the effect of that? Well, they're migrating at night because they're navigating by the stars. Many, many birds navigate by the stars. They navigate by other means as well, including using polarized light, which is also affected negatively by light pollution, including magnetic sensing. They have little mini compasses in their sensory system, and sensitivity to other environmental factors. But the fact is, many of them use the stars at night. What happens if they can't see the stars? Maybe they wind up like this yellow-throated vireo that I found dead on the sidewalk in Northampton after its multi-thousand-mile migration up from Central America or the Caribbean, only probably to get distracted, confused, pulled off course by the lights of Northampton and disoriented until it dropped dead from exhaustion or hit a building, crashed into the glass, and died. And this happens to upwards of 1 billion birds per year in the United States alone. This recent study found that artificial light at night is the second most important factor that predicts where birds are going to stop at the end of a day's journey. They're supposed to come down for daytime foraging and feeding and resting and then take to the skies again at night. But they're coming to the wrong places because they're attracted to places that have strong sky glow, which is to say light pollution. Here is a video. I'm here right now, as I said, in New York City with my mom. These are the pillars of light designed to commemorate the Twin Towers here in New York, and that are turned on for 9/11 memorials. And all those things in the light beam were birds. There are tens of thousands of birds that are trying to migrate at that time in September, and they get trapped in that light, confused until there are thousands and thousands of birds at any one time. Here's a bird watcher with binoculars counting them. And fortunately, when the density of birds gets too high, they actually turn the lights off for 20 minutes and let the birds go on and and continue their migration. But for many birds, the predictable result is that they will not survive that night. They'll die from exhaustion, they'll crash into a building. These birds are collected on the ground outside city buildings. These are all just from one night. What about mammals? 3/4 of mammals are nocturnal. Only 20% are diurnal, and the rest are crepuscular, somewhere in the middle. So this bat, of course, is nocturnal. And possums, foxes, they all need darkness at night for their natural uh, uh, habits. And that includes their reproduction and their hunting and their migrating and their feeding. The whole ecosystem, from the smallest to the largest things and all different species, depends on darkness at night. They're hardwired for it. It makes me so happy to know that these animals are in my backyard. We have a trail cam, and I just love to think about these coyotes and foxes and raccoons and everything else that I've seen on these trail cam videos right in my backyard at night. And it just reinforces my feeling, we got to protect the darkness at night. Have to keep talking with the neighbors about keeping the lights down in this natural area here. I love to go out and see the fireflies. I'm sure you all do as well. It's practically everyone's favorite kind of insect. And here are thousands and thousands of insects, of fireflies, on a warm July night in the middle of the Connecticut River, the island, Elwell Island, looking for mates. That's why they flash. They're looking for the flash of their particular species in response, so they can find each other and mate. In the presence of light pollution, they just go away. It's devastating for them. And in fact, there are some species of fireflies, whole species, threatened with extinction because of artificial light at night. There's a lot of talk these days about pollinators and the importance of protecting pollinators, protecting pollinator habitat, um, planting pollinator gardens. What many people don't realize, and now it's our job to help educate about this, is that pollinators are also devastated by artificial light at night. And this paper is written by some experts in Europe who did an experiment where they they put lights out in an alpine field, and they measured that the number of visits to flowers by pollinating insects dropped by 62% in the presence of the light at night, whereas it was, it was unchanged with natural darkness at night. So this got a lot of press, and it was written up in a bunch of articles like this one. And there are other researchers who have experimented with the brightness of light. It turns out that if you make the light brighter, it's worse. If you make it dimmer, it is better. The dimmer the light, the less the effect is on insects. So we often think that pollination is done by daytime insects like this monarch butterfly on the thistle. And what we don't think about is that when we plant a pollinator garden like this one in the middle of Northampton in our Pulaski Park, it's sort of like our commons. What we don't think is, right, we're attracting the pollinators by day with these nice plants, but then we're killing them at night by zapping them with these deathly light rays. These lights are 4,000 K. They're much too blue, and they're brighter than some lights right here in New York City. Some parks in New York City have better natural darkness than this park. And this is a similar result showing that in the presence of street lights, the numbers of moth caterpillars goes down. The horizontal line there is no change. And these different kinds of light in different kinds of circumstances show that's always bad. Whenever you add light to the natural area by the side of a road, you get fewer insects. Here, the insects are buzzing around the street light outside my house. And we all know what this looks like. It's normal, right? You see insects buzzing, they're attracted to the light, like moths to a flame. Most of those insects are not going to survive the night. They're going to, again, drop dead from exhaustion, or they're going to get picked off by other animals like bats that are predators. This is a list assembled by Avalon Owens here in Massachusetts, actually. She's at Harvard now, was a PhD at Tufts, of the myriad different ways that artificial light at night affects different kinds of insects in the insect world. And all these by different authors over many years in different publications. So it's a large body of literature. Again, this has gotten a lot of press about the insect apocalypse and how some of that is due to outdoor lighting. What about fish? Fish are also affected by light pollution. When you illuminate a bridge and the light shines down on the river, it acts like a barrier and it stops the fish from their migration. This is just a short list of some of the institutes devoted to studying the link between wildlife and light at night. The United Nations has recognized this in a number of different ways. Here are 3 reports at the UN level about the effect of light at night on the natural environment, with strong recommendations for how to turn back the tide of light pollution. Turning back the tide, that's the problem. It's going the wrong direction. Here is a map of the United States of light pollution in the 50s, in the 70s, in the 90s, and a prediction for 2025. This picture was made about 20 years ago, and sure enough, that's what it looks like today. If we look at a map of the U.S. and light pollution, that's what we see. It's wall-to-wall light east of the Mississippi. It's growing fast. This citizen science report from just a couple of years ago found that it was growing as fast as 10% per year, much faster than we thought it was, and 10 times faster than population growth. It's only 1% per year population growth. This also got a lot of press in international media. Well, let's take a look then let's zoom in a little bit on New England in this light pollution map.info website, which I really recommend you take a look at. It's great. It's fascinating you can go to any place in the world with this map and see what the light pollution is like. The white is the worst part, meaning the highest level of light pollution. You can see New York and Boston and Montreal in this map are the worst. Where's the best? Well, in the United States, east of the Mississippi, there are really only 2 parts, Maine in the upper right and the Adirondacks. Those are the darkest parts of the Northeast. Let's zoom in even more. Let's go to Maynard. So using, again, lightpollutionmap.info, that's the website. You go to Maynard, Massachusetts, there it is, and you can see the white light of Boston on the right. So, of course, the sky is really bright there. Maynard kind of in the middle. Well, can we quantify it? Yeah, you just click on that pin there, and these numbers pop up. And it tells you the brightness of the sky at night on a clear, moonless night. And it shows it in a bunch of different ways, a bunch of different units. Let's focus on the one called ratio. It says 5.45. What that means is the sky is 5 times brighter than naturally dark skies. And that corresponds to a Bortle class 5, as we said before, meaning the Milky Way, it's going to be a challenge to see the Milky Way from Maynard. Okay, how do we get here? Where's all this light coming from? We had a little preview at the beginning. Here's another check. This is my street, and looks nice and dark in this picture, doesn't it? That's because the street light was broken at that moment, but it was broken in a funny way. It would turn off and then it would turn on, and then it would turn off for 15 seconds and then on for 15 seconds. This is 10 years ago. It was an old high pressure sodium light, the kind that we'd grown up with for 50 years before this kind of yellowy pinkish hue. The real reason I took the picture is because I knew they were going to change the light. They were going to replace it with LED. Across the whole city, 2,000 street lights were going to be changed from high pressure sodium, the old one, to new LEDs. Here's what it looks like. Get ready. Here's the old one. That's the new one. That's the old one. That's the new one. Same exposure, same camera, same lens, much, much brighter, harsher light with a lot more glare. This was a bad day for me when this light got installed right outside my house. It's better now because we've been able to install shields around it so the glare is less, but it's still bad. Okay, how do we fix this problem? Here's another view of Pulaski Park in Northampton. looking at the beautiful pollinator garden, over illuminated by these harsh, bright blue, white post top lights all night long. How do we fix it? First of all, the light should go down only, not up or out. It should be not like this, but like this, down only. Not like this one here going up into the sky and into the neighbor's house, but like this one, down only. It should be not like these, but like this. Not like the one at the left, like the one at the right. And the green only. Don't shine light up into the sky, not the orange or the red. If you have lights on a hinge, which is not a good idea, but if you have one, make sure it's not installed like this at an angle, but like this, horizontal, perfectly horizontal. And think about the beam. It's not a narrow laser beam. It's a big, broad, wide cone, so that if you install the light at an angle, that cone shines light up into the sky. If you install the light horizontal, the light just goes down only. That's much better. It's better for glare and light trespass and sky glow and everything. These are not new concepts. We all know what it's like to go into live theater and you sit down in the audience and the lights go down, the house lights go down, and the stage lights come up, and you can see the performers on the stage. You're not blinded by the light. You can get a degree in theater lighting, and the number one rule is don't shine the light in the audience's eyes. So how does it work? How does theater lighting work? The light is carefully controlled for glare. The light is in a can facing the stage, not the audience. And you can see there's a picture of a theater light there with these shields to stop the light from going in the audience's eyes. The people on the stage can't see a thing. They're blinded by it, but that's not what matters. What matters is what do the audience see? We all know how to use a flashlight, right? You point it at the ground. That's the right way to use a flashlight. We do not use a flashlight like this, shining it in our own eyes. Why do we forget these basic rules when it comes to outdoor lighting? Why is it that we shine the flashlight directly in our eyes with our outdoor lights, like the lights on this church in Northampton? Rule number 2, we should minimize the amount of blue light at night. I would hate to live in this house, in this development on Hospital Hill in Northampton, next to that super bright, super blue, blinding, poorly shielded glare bomb shining directly into the bedroom all night long. The color matters a great deal. As we mentioned already, we use this number from 2,000 to 5,000 or more, and it's sometimes called warm for the low numbers, cool for the blue for the high numbers. Warm means the sort of more amber color. Cool means a more blue color. Do not use light more than 2,700K outdoors is the general rule of thumb, and ideally, actually go lower to like 2,200K. That's a nice mellow amber color. Fortunately, these exist. They're available, and many cities and towns are now actually passing laws that say, well, you're not allowed to use lights bluer than 2,700K. That's Northampton, for example, and some towns like Pepperell, close to you in Maynard, have actually installed streetlights at 2,200K. A lovely mellow color that is not blinding and minimizes melatonin suppression and minimizes sky glow. Shelburne Falls near me, same thing, 2,200K. So it exists, it's out there. You just have to make the choice to do it. Number 3, don't overlight. Use appropriate levels of brightness. If a certain amount of light is good, 10 times better than that, it doesn't make it 10 times better. 10 times brighter than that is not 10 times better. Turn the lights off when you don't need them. If your street lights are modern LEDs, you can probably get a little timer. That's that little black hat that sits on the top of the street light that will dim the light down by 50% or 75% in the middle of the night when the vast majority of people are in bed asleep. These rules are all summarized in what are called here the 5 principles of responsible outdoor lighting. And I won't read everything here, but the light should be useful, meaning, you don't just stick a light on the building for no reason. It should be over a doorway, over stairs, should have a real use. Targeted means shine it only in the direction you want, not in all directions. Low light levels, not brighter than you need. Controlled, meaning use timers and motion sensors and and dimmers to turn the lights dimmer or off when they're not needed, which could be most of the time. And color, use warm colors, no bluer than 2700K, ideally 22. Okay, Maynard, as Kathy mentioned, you are in the middle of the process of drafting and negotiating and discussing a new bylaw to control light pollution and protect natural darkness at night in the town of Maynard. And I am so happy that you're doing that. Congratulations. Thank you so much to all of you who are working on that. This is the latest version that I saw from just a week ago, and it borrows heavily from this template that we developed for Dark Sky, Massachusetts, that we call our contemporary outdoor lighting bylaw, which we developed over a couple of years, and it had a team of experts working on it, including at the national level, using best practices. And you've borrowed a lot of this, so I hope that it works well for you. You might also consider some other actions in Maynard. You might start a group devoted to protecting darkness at night. This is the one we have in Northampton City Lights. You're welcome to borrow any of our material. We put on a festival every year called Night Fest, and we ask our mayor every year to write a proclamation in support of darkness at night, and specifically in support of International Dark Sky Week, which is when we put our event on in April. There is also Dark Sky Week happening across Massachusetts, and here is the proclamation that the governor issued, recognizing International Dark Sky Week and talking about all the things we're talking about here tonight, the importance of protecting darkness at night. You could support the statewide bill that is perennially working its way through the state legislature called the Dark Sky Bill. It has not made it over the finish line yet, but we are optimistic. We have a lot of support from all across the state, a lot of legislators, a lot of organizations, a lot of cities and towns. Here is a resolution that that the city of Northampton passed a couple of years ago saying, yes, please, state, pass the law. We support it. We think it's good for our municipality to limit light pollution for all the following reasons. So Maynard could do a similar thing. Here's another sort of longer list of things you can do. Again, I won't read it. This will be, you can check this in the recording later, or I'll send you the list if you like. But one thing you might draw from the fact that there are a lot of bullet points here is there's no single silver bullet, as it were, that's going to solve light pollution. It's about culture change. It takes a lot of discussion and back and forth, and hearing it from different people and different neighbors and different organizations for it to really sink in and change the culture in your town. But you're doing it, and I applaud you for it. So to summarize, light pollution is bad for all these reasons, but it's easy to fix. It's a global problem with a local solution. You can fix light pollution by these simple rules, just using light only when it's needed and where it's needed, eliminate the glare, minimize the blue light, turn the lights off when they're not needed. It's so easy, and it's a win-win. So I'm going to leave you then with this view over the Connecticut River of a comet that many of you might have seen during the early days of COVID, when we were all desperate for human contact, and the only way you could really do it safely was outdoors. And so a lot of people took up stargazing, and a lot of people went to look at this comet, and it's something that united people all around the world. And what a joy it was to see it. Of course, we had a little bit of a challenge. The light pollution was still there despite COVID, and you still had to get out of town, which I did, but a lot of other people did too. And my dream is that we don't have to leave town to see the next big comet, that we can just step outside our doors and look up. Thank you so much for your attention. Thank you for your help in solving this problem. And I am so happy now to uh, stop the share, and I'm going to check the Q&A, and I'm going to wait to see if any of you have questions that you want to ask now, and we can just have a little discussion.
I have one question.
Please go ahead, Kathy. Yes.
And that is that from everybody I've talked to in Maynard, nobody has said this isn't a good idea. Everybody thinks it's a good idea. But we don't have the funding to go invest in new lights, right? And Massachusetts has things for energy conservation, and is there while you're getting that law, try to get that passed, is there any effort to provide funding for towns to invest in different lighting?
Yes, I mentioned, for example, near me, Shelburne, which recently converted their old high pressure sodium streetlights to really good state-of-the-art LED streetlights. And they chose really excellent ones that are 2200K. That's a good color. They're not too bright. They're well shielded against glare. It was an $80,000 project, and they paid $2,000 for it. All of the
Oh,
rest came from grants, mostly state grants. And I can get the details for you, but yes, there are
yeah.
grants available. There used to be, yeah, it's a long story, and it's
Well, we can talk offline, but I'd be
okay.
interested in hearing about those. That'd be really good. Yeah, because that's our biggest stumbling block is
Yeah,
paying for it.
yeah. There's all kinds of good news there. For example, the good lights, they don't cost any more than bad lights. For example, Pepperell.
Mhm.
Pepperell was going to do a conversion from old high pressure sodium to new LEDs. They were going to do it anyway. And the dark sky advocates like me in their town, that's Tim Brothers and his colleagues, um, convinced the town to do a demonstration. Could you at least do a pilot where you try at least say 6 or 8 or 10 different kinds of lights and let the public vote about what they like the best? So they did that, and guess what? The public liked the ones with the least glare and the least blue and the dimmest ones. Those were the ones they overwhelmingly chose. And guess what? Those were the cheapest ones. So the town actually saved money by going with the better lights. So
Right.
they're and then they're going to save money. They save more money going forward because those lights use less electricity because they're less wasteful. They're sending the light down only. They're not super bright, and so they save the town when they buy them and for their whole lifetime, which could be more than 10 years.
Mhm. And there is a question here about, is this recorded? And yes, it is recorded. And I hope you share, once it's available, I hope you share it with your friends.
Uh, Kathy, Sally, any other questions?
I don't see any other questions. What I would like to say is we are working on this bylaw. We will have information at uh, Green Maynard will be at two different farmers markets during the summer, so we will be there. If you want to come talk to us about what we're doing, and then I can also I'll put my email in the chat here if anybody
I-
wants to, reach out to me later about what we're doing in Maynard. Did I
Thank you,
spell
Kathy. That's
everything right?
excellent. I do also see Carrie Stamos is one of our attendees who has a hand up. And
Oh,
Carrie,
okay, great.
are you able to type with the system you have? Ah, okay, the hand came down. Okay, no, that's fine. Apologies, no apologies needed. Kate Wheeler, thank you so very much. You're so welcome. Thanks for coming tonight. All right.
Sally, how will people know where the recording is? Will that be on the library website?
Yeah, so I'll put it on our YouTube channel and then send everyone the link to that, everyone that
Perfect.
registered.
All right.
And it
Okay.
will be available to anybody who has the link. So it's easy to share.
All right, great. Yeah, because I'm scheduling meetings with a lot of the people in town in town positions, and they're all on vacation this week, so they couldn't come. So,
That's fine. We can continue the discussion.
right,
It's not a make or break if they're not here tonight.
right. Well, thank you very much, James. This was just a wonderful presentation. I think.
So welcome. Thank you so much for hosting me and for the good work that you're doing there in Maynard. And I look forward to being in touch with you and everybody else in the months and years to come because it sounds like you're going to make some really good changes in town.
All right, thank you.
Thank you, James.
Bye,
Good night,
everybody.
everyone.